Hey guys, so today all I'm going to be looking at is the quiz that you're going to be writing on balancing equations. I'm sorry, this is assignment, it's supposed to say quiz. What we're going to be doing is I'm going to be assigning you 3 questions from your balancing equation problems sheet from last week, which was only 6 questions long. And what you're going to have to do is you're going to have to rank them from least to most difficult and explain why you ranked it that difficulty. You have to show me how you did it. So show me the skeleton equation and show me the balanced equation. So I do have it written out here. Whoops. You will not be doing an extension to Lab C because, as you know, we haven't been able to do a lab. So as you can see, this document has a few different things. It just says the lowest difficulty one, write the equation down, skeleton equation, balance the equation, how did you solve it, and why do you think it was the easiest of the 3, and then the medium difficulty one, and then the highest difficulty one. And that's all it is. So if you don't have a printer, don't worry about it. You can just do this online piece of paper. So I need the equation, the skeleton equation, the balanced equation, how did you do it? So you have to write out how you did it and why did you rank it that way. I'm not only going to be looking at your answers to see if they're correct or not, but I'm also going to be looking at these rubrics, being able to transfer and apply learning to new situations and communicate scientific ideas. I do warn you that I made sure when I assigned you guys the questions, I did not assign anyone the same 3 questions. So how easy or how difficult things are really depends on what other questions you were assigned. So be very careful about that. You will, I do believe I'm just going to put the question numbers at the bottom of your mark update that I'm going to send home so that you can ask your parents, or if you see it yourself, you'll know what 3 numbers to do. So today we're going over salts. So salts are ionic compounds formed when acids and bases react, or when oxides or carbonates react with acids, or when metals react with acids. So it's quite a few different things. So when acids and bases react, when oxides or carbonates react with acids, or when metals react with acid. So there's one type of salt that you're probably the most familiar with, and that's table salt. So table salt which is our sodium chloride, is one type of salt. And this is found in seawater, lakes. You guys have, if you've had breakfast or lunch already, you've probably ingested it, unless you've had just plain fruits and vegetables. We find it in almost all processed food, and we add it to a lot of meats as a preservative, as well as taste. So, the reason why we're doing salts next is because last video we talked about acids and bases, and when we combine the two we make a salt. So this is called a acid, base, neutralization. Basically, we're taking how we did that hydrogen plus hydroxide gives you water, and we're adding in one more thing. So neutralization reactions occur when an acid and a base react and they produce a salt and water. So an acid plus base become salt and water. And this is always going to be the case for this level. So if we take HCl, hydrochloric acid, which is an aqueous, and we add NaOH, sodium hydroxide, which is also aqueous, we will get NaCl, which is our sodium chloride, which is a solid, it's our salt, and we have our H2O, which of course is a liquid. So if you look, we have our acid, we have our base, we have our salt, and we have our water. And this is just like before. If you look, we take our hydrogen and our OH, and that forms our H2O. And then we take our chlorine and our sodium, and that forms our salt. Excuse me. So for metal oxides, it's a little bit different. What happens is the metal oxides will react with water, to form bases. So if we have Na2O, so a metal oxide is a metal with oxygen. So I have our sodium oxide, which is a solid, and I put it in water, which is a liquid. I will get 2 sodium hydroxides in aqueous. So again, we're taking our Na and we're taking an OH from there. If we take an OH from there, we're left with an extra H, but good thing this oxide has an O, and that will give us our NaOH. But if you look, I still have to balance it, which is why that one lesson was so important and why today was the quiz for it. Because we're still going to be balancing, and this is going to continue throughout our unit. So non-metal oxides these guys react with water to form acid. So if it's a metal, it'll form a base. If it's a non-metal, it'll form an acid. So if I take SO2, which is sulfur dioxide, it's found as a gas, and I add water, which is a liquid, I'm going to be left with H2SO3 in aqueous. So I'm left with an acid. So non-metal oxides like this are frequently formed by burning of fossil fuels. So what happens is when this is released into the atmosphere, we have water in our atmosphere, don't we? Water vapor. And so it reacts with that water and will form an acid, and that's how we actually get acid rain. Which is rather interesting, I think. Okay, so acids and metals. So the most reactive metals at the bottom of groups 1 and 2 react vigorously with water and acids. All the other metals are less reactive than those in groups 1 and 2. But when metals do react with acid, hydrogen gas is usually released. If you were in grade 9 last year, you should have been with either Mr. Watson or myself. Both of us generally do the sodium in water. He makes it explode and break the beaker. I just let it light on fire, but those are some of the most reactive ones because remember it is in group 1. So if we have HCl plus magnesium, which is in group 2, I'm going to end up with MgCl2 and hydrogen gas. So basically, if you look, the hydrogen is released by itself, and then the chlorine and the magnesium pair up. So this magnesium is replacing this hydrogen. But again, this has to be balanced, and right now I have 2 chlorines over here and 2 hydrogens over here, but only 1. So I need to put my coefficient. So acids and carbonates. So what happens with acids and carbonates is that they actually neutralize the acids and produce carbon dioxide. So if we take sulfuric acid, and we add calcium carbonate, we're going to end up with calcium sulfate, water, and carbon dioxide. And remember, carbon dioxide, when it's in our atmosphere, it reacts, and when it's in our oceans, it reacts with water and will form acid. That's just going straight back to our non-metal oxides, reacting with water to form our acid. But yes, acids and carbonates will neutralize the acid, but form carbon dioxide, which again produces our acid rain. So today's assignment, other than you guys writing your quiz, which I go over at the beginning of this video, there's a 1-page assignment for you in the Google Drive. It's all about identifying what's an acid, a base, and a salt, and then finishing off neutralization equations, including balancing them. So if you have any problems, please let me know, and I will talk to you guys later in the week.